Okay, in lesson 2.1, we're going to talk about something called inductive reasoning. And inductive reasoning is the process of observing things, data usually, recognizing the pattern that's associated, and making a generalization about that. So you watch something happen, and then you make some kind of statement about it. For example, let's say you look at the pattern 2, 4, 7, 11. We notice that we're adding 2 the first time, and then 3 the next time, and then 4 the next time, and so on and so forth. And we come up with a conjecture that the next 3 terms will be produced by adding 5, and then 6, and then 7, which are the numbers 16, 22, and 29. So we observed a sequence that had a certain pattern. That is, that we saw the pattern add 2, add 3, add 4, and we noticed that the adding went up by 1 each time, and so that's how we figured out that we're going to be adding 5, 6, and 7. That's called inductive reasoning. In this next example, we see some figures, and if the figures down below were continued, what would the next shape be, or the next couple shapes, and how did you know it? What about the 31st and the 32nd shape? So as I look at this, what I notice is if we look at the first shape, we see it's a circle. If we look at the second shape, we notice that it's a triangle. The third shape is a circle again. The fourth shape is a four-sided figure, polygon that is. The fifth shape is the circle again. The sixth shape is the pentagon. And then the seventh, eighth shapes are back to circles and another polygon, a hexagon. So we notice that every odd shape, 1, 3, 5, 7, so on and so forth, are circles. And what we notice is that in the first time we see the circle, we notice that the top half is shaded. And then we notice that the right side is shaded. And then the bottom is shaded. And then that the left is shaded. So we notice that the shading is rotating around clockwise. Likewise, in the even terms, we notice that every even term is a polygon starting with 3 sides and then going up by 1 side each time. So we have 3 sides on the triangle, 4 sides on what looks like a square, but it's a quadrilateral for sure. Then we have 5 sides on the pentagon, and then we have on the hexagon 6 sides. So as we look and see what's happening, the 31st figure, because it's odd, would be a circle, and then we just have to find out or make the conjecture about where the shading would be. And as you can see in our 31st picture here, based on assumptions of what we see happening, I noticed that the shading should be on the left-hand side, so you can go through and see how many circles there would be, and every 4th circle, on the 5th one, we'd start all over again. And then on the even ones, there is another pattern, and what you find out is that if you divide the number of sides, which I like to call n, so if I'm talking about n, which you see here in this equation or formula, this stands for the number of sides. So if you take the number of sides and divide that by 2, like for example with the triangle, or sorry, not the number of sides, I said number of sides. The term number is what I meant. Pardon me, the number of the term. So the first polygon was a triangle, it was the second term. And so if I take that and I were to divide that by 2, and then add 1, I notice I would have a 3. So if I want the 32nd term, 32 divided by 2 is 16 plus 2 means the 32nd term, or picture, I guess, in this sequence, would be a 18-sided figure. So this is just giving you a demonstration that you look at a certain pattern with pictures. Kind of the most important thing out of this whole example is not what the actual answer is, but how you do it. You look at the pictures and you say to yourself, oh, I see a pattern. and if I continue this pattern, this is what I should see. That's called inductive reasoning. And later we're going to talk about deductive reasoning, which is a little bit different.